Hi there, my name is Finn Yingek, and this is my Physics 2212 lab video for Lab 5. So here I'm just going to outline what I'll be going over in the video. I'm going to explain the lab procedure itself. I'll reveal the observations of the experiment, discuss some fundamental physics principles and equations, and then I'll show the glow script code and produced model for this situation, and finally answer some lingering questions. The experiment was needed an aluminum foil roll, a bar magnet, and a recording device. And it was just time trials of dropping the bar magnet through the foil roll and recording the fall time and doing the same thing, but without the roll as a control set, and determine what effect the aluminum roll has on the trajectory of the falling bar magnet. So here's the observations. So when dropped through the aluminum tube in all trials, the magnet fell much slower compared to when it was dropped outside of the tube. And so this would suggest that there's a force opposing the fall of the magnet due to the electrical and magnetic interactions between the tube and the magnet. So the physics principles at play here are Faraday's law, which states that the EMF is equal to the negative rate of change of flux through a circuit. So the circuit here being around the aluminum roll, and the EMF is going to be produced by the magnetic field's interaction with the roll. And then Lenz's law, which says that the induced B field in a loop of wire will oppose the change in magnetic flux through the loop. So this makes sense with our observations where we noticed that it was falling slower through the tube because there's a force opposing its moving through the tube, which is also causing change in flux downwards. So it's opposing that. So here's some of the glow script models. On the right shows the display, and on the left here we've got it's calculating the magnetic field due to the magnet, and then from that the changing flux for each time step. So then it will produce a velocity versus time graph, which is part of our observations. Some additional questions. So what if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? So if the resistivity were reduced to zero, it would cause the voltage to be well, we have Ohm's law, which says that the potential is equal to the current times the resistance. So if it was reduced all the way to zero, or as close as possible to zero, in order for the voltage to be the same, which is the EMF, the current would have to be very great. So the current around the tube would be increased a lot, and this would cause, if the current was increased, the velocity of the particles of the electrons going around the circuit would result in a stronger magnetic force pointing back at the magnet, so it would actually fall slower as the resistance was decreased. And what if holes or slots were cut into the tube? How would this affect the ring currents in your model? I suspect that this could be akin to increasing the resistance in the tube, which would make the opposing magnetic force in the upward direction lesser in magnitude, so the magnet would fall slower and it would approach the regular fall speed due to gravity. That concludes my physics video. Thank you very much.